Great. Hi, I'm Colin Eberhardt. I'm the CTO of Scott Logic, and I've traveled a long way to be here, around about 200 meters from a building just next door. And today I want to talk a little bit about how AI is disrupting the world of software engineering. And just out of interest, hands up if you write code or work in an organization that has people writing code. All right. I've got the right room then. Fantastic. A little bit of background. So to introduce Scott Logic, we're a UK-based consultancy. As I said, we're based in a building just a couple of hundred meters away, UK headquarters, and our heritage is predominantly working in financial services. So organizations like Morgan Stanley, Goldman Sachs, JP Morgan, also public sector. And generally speaking, we work on sort of fairly large scale, challenging enterprise systems. So as a CTO, my job is to sort of work out what it is our customers are going to want in 6 months' time or a few years' time. And funnily enough, the only thing I'm interested in at the moment is AI, and more as that's what everyone's interested in. And more specifically, my job for probably the last 6 months has been almost exclusively looking at the application of AI to software engineering and helping organizations increase their velocity through the use of AI. And here are just a couple of examples. One of them is a German ERP provider that we worked with over a number of months, and they're now delivering features 3.4 times faster than they did previously. It takes a fifth of the time to actually create the requirements because we've created a system whereby business analysts can actually get closer to the product itself, and 6.6 fewer bugs as well. So speed and quality. And then on the right-hand side, this is a Rotterdam-based SaaS company that does finance and accounting. 1.7 times faster on a migration project, 37% fewer bugs per user story. We're doing a lot of this. And to be honest, I mean, I've been in software for 20 years. And personally, I think this is one of the most exciting times there has been in software. Things are changing so fast, but also it's a little bit unsettling at the same time. The change means that our role is changing and the way that we create software is changing incredibly quickly. And that gets me onto the subject of my talk. I want to take out a crystal ball and start looking at what the impact might be in a few years' time. So not talking about what's happening now or what we're doing now. I want to look a little bit further ahead and share a few sort of strong opinions and radical thoughts about what the world might look like in the future. And I've road tested these thoughts with a few people and chatted in hallways, and they've worked quite well. I've had quite a few people nodding and agreeing, and just as many arguments. So I've enjoyed that. So if you want to, if you want to get into an argument about some of these ideas afterwards, I'm very happy to do so. But let's start with a brief history of how we got here, because a lot has happened in a very short space of time. So GPT-3 was sort of effectively heralded generative AI for the masses back in 2020. And it was in 2022 that we saw the release of ChatGPT and Copilot, basically putting this technology in the hands of your average user. And at that time, Copilot for a software developer focused on sort of line by line and function level code completion. That was the level of assistance that you got. The developers remained fully in control, and the AI suggestions were assistive and not directive. And it created a modest productivity boost. You know, people were maybe 10%, 20% faster. The year later, we saw GPT-4 launched, and that had a significant improvement in code generation quality. Also, GitHub Copilot introduced a chat mode, which created a bit of a paradigm shift. Rather than code completion, you could actually talk to your AI assistant and it would write a modest amount of code for you. 2024, things started to accelerate significantly. We got GPT-4o, which had really good reasoning capabilities, Claude 3 as well. We had speed, we had longer context windows, which allowed them to explore larger quantities of your code base. But we also saw tools like Cursor, Lovable, and Bolt come along, reimagining the way that you work as a developer. Those tools are effectively AI first rather than editor first. We also saw the advent of RAG, which was mentioned in one of the lightning talks, that allows AI agents to operate over larger code bases. And here we shifted from AI helping to end-to-end developer assistance. And last year, things went up even further, a bigger notch. We started to develop workflows that allowed us to make the most of this technology, plan, code, test, refine. They're spec-driven development. You may have heard of the concept of an agentic loop, where you have a reasoning model that has access to tools, potentially through MCP, and is able to iterate autonomously towards a long-term goal. developers moved from prompt engineering through context engineering to harness engineering. And probably the most fundamental shift is we went from a synchronous way of working with AI, so basically a back and forth, to asynchronous, out of the loop. You delegate a task to the AI agent and you go and do something else and it comes back later with a result. And you might delegate to a fleet of agents, again, as one of the lightning talks outlined. So late last year, we hit what was widely recognized as a bit of an inflection point. Researchers, journalists, the model companies and the engineers pointed to sort of November 2025 was seen as a turning point where autonomous agentic workflows were able to operate autonomously at repository scale. It was seen as a realization that software development is fundamentally changing from writing code to directing systems that produce the code on our behalf. And that was something that I think is around about 9 months ago that inflection point occurred. And I think one of the most stark realizations is that the cost of code has rapidly dropped to zero. So code used to be a highly valuable artifact. If you know, back of envelope calculation, it costs between 10 to 50 pounds per line of code based on typical productivity metrics. As of late last year, that's gone. It's no longer 50 pounds a line, it's close to zero. And as a result, the economics have upended completely. But there's a catch, and a fairly fundamental catch. The cost of code has dropped to zero under some very specific conditions. You can very easily create 1 million lines of code using Claude Code far faster than ever before. You can write 1 million lines of code in a few hours. It'll cost you a fair bit, but you can write it in a few hours, but it's still hard to create the right thing. So you may have seen some of the recent news stories. For example, Cloudflare rebuilt Next.js in a week. Anthropic rebuilt a C compiler in the space of 2 weeks. These are perfect examples of comprehensive test suites that create an agentic feedback loop that allow the AI agent to validate its output and create 1 million lines of the right code in a very short space of time. Most of us don't have that luxury of a comprehensive test suite, predefined requirements. It's a change in economics that's going to take quite a while to get used to. So this is my own view on the inflection point and what we need to do about it. We need to replace the processes and practices that we've built around our own strengths and weaknesses and replace them with processes and practices based around the strengths and weaknesses of AI. And that's a difficult thing to achieve. And giving you a few concrete examples, almost everything about the way that we develop software is, funnily enough, based on our own strengths and weaknesses. If you look at team sizes, there's a classic notion of a 2-pizza team. I think that's about 8 to 10 individuals. And that's based on the competing factors of individual productivity and coordination overhead. If AI massively increases individual productivity, but doesn't have an impact on coordination overhead, team sizes naturally get a lot smaller. Code review. Code review is again based around human strengths and weaknesses. In the short term, we use it to identify whether one of our colleagues has introduced a bug. And in the long term, we use it to shape the code base for an easier understanding of the entire team. Now, AI is great at fixing bugs, and it doesn't suffer from the same cognitive barriers that we do. Code review, I think, is going to change. We need to focus on the conditions for making AI succeed. Now, how is this change going to manifest? It's not going to be easy, and I think it's roughly speaking going to follow 3 phases. The first one is introducing, and this is effectively adopting the tools. Basically, give people access to Claude Code, GitHub Copilot. But what you'll find is developers will typically still operate in a sort of pair programming mode. They might try to create agentic loops or harnesses, but these are new skills, and it takes time to acquire new skills, and most people are busy with a day job. Also, if they try to put these practices in place, they will find bottlenecks elsewhere in their organization that block them, which is why a lot of organizations, the more mature organizations, are adapting. And some of the stats that I showed you earlier of some of the organizations we've worked with, I'd say they're very much at the adapting stage. They're taking their existing software development lifecycle and addressing the bottlenecks. They're bolstering test coverage. They're improving automation, containerization, virtual environments. And this takes a while, but there's a big prize at the end of it because it unlocks fairly significant productivity gains. But I want to talk about the final step here, reshaping. And the thing I find interesting about this is I don't think any of us are there yet, but that's the one that interests me the most, because I think some of us will be getting there very, very soon. This is where we take an even bigger step back and look at the broader impact of AI on the whole organization of software engineering. So what does the new world look like? Well, it's a great question. And funnily enough, I don't have a terribly clear picture. I don't have a blueprint, but I have a collection of principles. Now, is anyone familiar with the Agile Manifesto? Is it? Yeah, fantastic. Okay, so what I've done is I've framed it in a similar way to the Agile Manifesto. And what I quite like about that is the Agile Manifesto was a way of framing a significant shift in the way that we develop software, but it was carefully done as a collection of principles that basically state this thing now matters more and this thing matters less. It wasn't a blueprint. It was a set of principles, and those principles have pretty much remained true for around about 20 years. So I think it's a good way of looking at a significant industry shift. So let's try a few. As I said, we can see if you agree with me at the end of the talk. So I'm going to start with the impact on the individual. I think the individual is going to be spending far more time shaping systems rather than writing code. And I think that's pretty obvious. We will be spending less time writing code. And to be honest, this is one that I think, understandably, people find a little bit uncomfortable, because writing code for a lot of people is somewhat core to their identity. It's what makes us engineers. In my view, engineering isn't dead, and software engineering hasn't gone away, but it's changed and our focus has changed. In the future, and again, some of the projects I was talking about there, we did a huge amount of engineering, but we were spending time on engineering the harness, not engineering the code itself. We'll spend more time on defining system behavior and architecture and shaping the code at a higher level. The next thing, product thinking over delivery thinking. Historically, software engineering has been delivery constrained. As I said, the cost of writing code has been very, very high. We used to ask, how do we deliver this efficiently? In the future, I think we'll be spending more time asking ourselves, is this the right thing to build in the first place? I think there'll be less focus on just completing tickets and more focus on solving genuine user problems. And what that means for the individual, for the engineer, is I think there'll be a greater emphasis on communication skills, imagination, and product thinking. And then finally, again, this one gets me into a lot of arguments. I think we'll spend more time validating outcome rather than reviewing code. Now, the concept of pull requests and code review has been central to our way of working for many, many years. And I think some people find it an uncomfortable idea that we might be shifting away from it. But I think we have to move away from, does this look right, to does it work as expected? We need to invest in test automation, simulation, observability, and judge quality by system behavior rather than line-by-line code review. I think we'll still look at the code, but we will look at it through a slightly different lens. We will look at it through the lens of architectural principles. And I think this is an interesting area because I don't think we have the tools to support what we need to do with AI. The only tool you have is a diff, and it's very hard when you're looking at a diff to determine whether it conforms to your design, your architecture. I think there's massive scope for creativity if someone wants to build a tool to do this. Also, there was a lightning talk that mentions the path of a junior engineer. And I think that's really interesting because I think we need to find a way to accelerate acquiring the skills that it took people like me 10 to 15 years to acquire: hands-on keyboard, system thinking, architecture, security. We need to find a way for people to gain those skills in a year or two, not 10 or 15. We just don't have the time anymore. If we take a step back and look at the team, fast feedback over upfront uncertainty. So what I mean by that is I think we'll need less detail and less upfront design because we could change things far quicker than we ever could in the past. That lends itself to rapid iteration rather than time spent crafting a requirement. You can generate and regenerate the code very, very quickly. This should happen through short sort of build, test, learn loops. And again, you can see why some of the engineer skills that I mentioned are more important in the future. We'll spend more time prototyping and validating ideas early and accept rework as normal rather than something that should be frowned upon. Breadth of perspective over narrow specialisms. So current teams are full of specialists, whether they're language specialists or someone who identifies as a back-end or a front-end engineer or DevOps engineer. I think we'll have much less reliance on that in the future. More generalist capability will be supplemented by AI to fill the low-level expertise gaps. So what that means is a lot of the tasks that were only accessible to specialists are now accessible to more of us. So what that means is diversity of, I want to be very careful here though. I don't think that that means that everyone in the team will be the same and think the same. Diversity of thought and viewpoint will be important, but it will not be encapsulated in a pithy job title. Empowered individuals over bloated teams. As I already mentioned, I think team sizes are going to reduce significantly. I think we're going to be looking at teams of perhaps 2 to 4 rather than 6 to 10. And there's significant advantage of that. Less coordination, fewer meetings, faster decisions, and much more rapid progress. Contextual judgment over standardized process. And again, this is one that I get into a lot of arguments about, because a lot of organizations want to know what is the new process for using AI. And I don't think there is a new process for using AI. I think this is a moment in time where we can be a bit more creative and create micro processes that are appropriate for the task that a team are delivering. And one of the most important sort of vectors to consider here is you can use risk as a useful vector to determine a suitable process for a team. So to give you an example, if you're working on a very low risk piece of code, let's say, for example, it's an internal tool for updating systems. And again, most organizations do quite a bit of internal dev work. I'd say don't do any code review. Just prototype, build it, ship it. Something of medium risk, something client facing. You probably want comprehensive test coverage, but you probably wouldn't review all the lines of code. If you're doing something high risk, a payments platform or something with PII, you definitely need rigorous validation and code review. But again, I think teams should shift from being process followers to risk managers, as an example. And then taking a step further back at the organization level, I think we need to embrace continuous transformation over one-time change, because everything I've mentioned here is going to take a long time. You need time for people to learn new skills and become comfortable in the new roles. You need time to fix some of the broken foundations that we've been putting up with for a long time. You know, loads of you will be in organizations where the tests are slow or the environments are slow or you can't get test data. The problems that we face are even more critical for AI because it moves at a faster pace. We need time to reorganize. And again, reorganizing people takes a lot longer than changing a config file to reorganize your cloud deployment. So the cost of code is now zero, but that isn't quite true. The costs do roll up. You also need to consider the tooling costs for AI, for example. So yeah, that's quite a lot of change. And at the moment, I don't expect any or many of us to be really embracing some of these changes quite yet. Most of us, as I said, are at the introducing or at the adapting stage. But I do think we should at times take a moment to consider the bigger shifts that are happening. So for individuals, think about the skills that we need as this change is underway. For teams, we need to rethink our ways of working. And for the industry, we need to build software. Well, we need to take a step back and consider that the way we build software is going to change radically, and it's going to change really quite soon. So yeah, hopefully that's given you some food for thought and you've found those principles interesting. As I said, very keen to debate, and if you agree with them, great. If you disagree, then come and have a quick debate with myself. Couple of things. We've got an event in London in a few weeks' time. I've got a newsletter and you can find me on LinkedIn. So thank you very much.